Good afternoon, good morning, whatever it is. Today we're going to talk about Stats Lesson 3, which is all about box plots or box and whisker plots. For the first part here, we've got this little warm-up. This one reviews everything that we talked about from the Stats Intro lesson and then Stats Lesson 1 and 2. So what I would do is pause this video, complete these, and then come back and I will go over them. So hopefully you've had a chance to do these. It does help. The whole point of these is we want you to actually get a chance to work through these on your own before the actual quiz and the test, which is coming up pretty soon here. So I'm going to just start off with these. We're going to write the data in order from lowest to highest. There are 12 numbers here, so hopefully make sure that you actually get all 12 written down. There's 1, 2, 3 threes, 1, 1, 2 twos, 3 threes, a 4, a 6, a 7, a 9, and 2 10s, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. So I got those all. When we create our dot plot, remember we're just going ahead and putting dots for each data point, each value. So there's a 1, 2 twos, 3 threes, a 4, a 6, a 7, a 9, and 2 10s. There's no 5s, there's no 8s. Leave those alone. Up next, we're going to go ahead and create the mean or find the mean. In this case, you would normally have to add all those up. Just to make this easier, we've added them up for you, and the sum is 60. So the mean is just to take the sum of all the numbers divided by how many numbers there are, which in this case gives us 5. So the mean is the average. For the median, we are looking at our middle number. In this case, there's 12 numbers. So there's kind of 2 in the middle. The 3 and the 4 are in the middle. And so to find the median, we add those together and divide by 2. And so that is 3.5. It's the number directly between the 3 and the 4. Our mode is the most frequently occurring number, which looking at our dot plot, that makes 3. And then the range is the spread from the lowest to the highest value. So I take the highest value, subtract the lowest value. That means my range is 9. Then we're going to move on here and talk about histograms. So we're going to create a frequency table. We're just going to count up the numbers between 0 and 2. And so I've got them here in order. That makes it pretty easy. So 1, 2, 3 values there. Between 3 and 4, there are 4 of them. So 3 3s and a 4. Between 5 and 6, there's only 1. It's a 6. Between 7 and 8, there's 1. It's a 7. And then between 9 and 10, there are 3, because there's a 9 and 2 10s. And then when we create our histogram, we're going to go ahead and put our bins at the bottom here. And on our y-axis, I'm going to go up to 5, even though the highest is 4, because going up to 5 just seems like the thing to do. And then when we make our bars, we're trying to make these all about the same width and for sure touching each other. So I'm just going to go ahead and create the bars. That one's 1 tall, this one's 1 tall, and this one is 3 tall. So there's our histogram. One thing I always want to kind of point out at this point is if you look at the general shape of that histogram and compare it to the general shape of that dot plot, you're going to see those are both very similar things. The dot plot is really just a kind of almost histogram, but with whole numbers, and our bins are always just 1 number each. So you can see the shape of those looks very, very similar. So today we are going to go ahead and talk about box plots. And so for our box plot here, you can see this shape in the middle is called the box. We've got 2 whiskers going out each way there. And so a box plot is just a way to show the range, or we could call it the spread, of our data by percentages. And in this case, we're going to be splitting our data up into 4 equal pieces. So there's going to be a quarter of our data down here, or 25% of our data down here. 25% of our data is going to be in there. 25% of our data is going to be in there, and then the last 25% is going to be here. So we're splitting our data up into quarters, and when we actually put this on a number line, we're going to be able to see things like, oh, the bottom quarter is really spread out, but the top quarter is really packed in close together, things like that. A couple other things we want to mention here is that when we do a box plot, usually we're talking about some larger sets of data. We don't want to try to do a box plot with only 5 numbers because we're not really seeing all that much. And I think I will, hopefully I remember the last one in a second. There's one more thing I wanted to mention there. So as we move on here, we're going to talk about the different numbers that you're going to see on here. This box and whisker plot represents our entire range. So this lowest point here is our minimum. This highest point up here is our maximum. Right in the middle, we know our middle value is the median. And then the two new ones that we haven't talked about are the first quartile, so Q1. Why is it not working? There's a dead spot in my screen. So that's Q1 right there. And Q3 over there. Now if you're thinking to yourself, where's Q2? Well, remember that's the median. Q2, or the second quartile, 2 out of 4 is the middle. That's the median. When we're looking at these, this is the part we call the box. Obviously, it's got a box, and then these things here are the whiskers. We can go ahead and write that down if we want to. So this whole thing here is called the box. And then we've got whisker, whisker. And there we go. Down at the bottom here, we're talking about our 5-number summary. These are the numbers that I just put in orange up at the top there. So I'm going to switch back to orange, actually. Our median, we already know. That is the middle value. The lower extreme is just another term for the minimum value. And the upper extreme is another term for the maximum. Maximum value. We'll try that. Now the two new ones, the lower quartile and the upper quartile, are the quarter waypoints. So for an actual definition here, I'm going to say that the lower quartile is the median. The median of the lower half of data, and the upper quartile is the median of the upper half of data. The median splits that data exactly in half, and then if we split each half in half again, those points are called the quartiles, because a half of a half is a quarter. And the final thing on this screen here is that interquartile range. The interquartile range is just the range or the spread of the box. Right. It's the difference between Q3 and Q1, and it's also the middle 50% of our data. So that interquartile range, a lot of times we're actually interested a lot in that interquartile range. We want to know where is the middle chunk of our data going to be. We use that a lot. Okay, moving on here, we got some examples. So here we're going to compare these two box plots, and these box plots show some test scores grouped by afternoon classes and morning classes. And so if you make some comparisons, I want you just to kind of pause the video, think about some different comparisons we can make about these two test scores based just on the pictures we're getting. So when you look at these two box plots, one of the first things you probably notice is that those afternoon scores, generally speaking, are lower. Now that doesn't mean that all of our afternoon scores were lower than all of our morning scores. Right? We've got, that person there scored, looks like about 95%. They did pretty well. They scored better than most of the morning class. But you can kind of see, in general, all these points are a little bit lower than their corresponding points in the morning. One of the things we could really care about or look at a lot is this median value. So we might say something like the afternoon or the PM median is less than the AM or the morning median. I'm going to put PM, AM, AM. We also might want to look at our lowest values. So the minimum for like the lowest value in the afternoon, the PM minimum is lower than the AM minimum. And in fact, our highest scores are also the same way. The highest score in the afternoon, the PM max, is less than our AM max. The one thing about our PM scores that's actually bigger than our AM scores is our range. So the range of values in our afternoon classes is actually bigger than our range for our morning classes. And when we're talking about test scores, that's a bad thing. We don't want the range of test scores to be very high. I would love it if all of your test scores were between 85 and 100. I really don't want to see test scores ranging all the way from 100 down to the 50s. And so something's going on in the morning. You might want to make a hypothesis. What do you think's happening in that afternoon class that's making those scores more spread out and generally lower on average than in our morning? Okay, last two examples here, we're going to create some box plots. We're going to do this one with Desmos, and we'll do the next one by hand, and kind of talk about how we can do that. So I'm going to go ahead and pull up Desmos, and you can see I have already created this list of values in Desmos using that same way we did last week, so capital L equals, and I'm just doing square brackets. To get that 5-number summary that I want, all I have to do is type in stats parenthesis L. And that goes and brings up that 5-number summary for me. If I want, I can also look in here under functions if I find statistics, and you'll see, well, there's stats right there. So stats in this case is our 5-number summary. If I go back over here, my minimum was 3, it was 4, copy these over, 8, 9.5, and my maximum was 10. So to create my box plot, I always start with the middle box part. So I'm going to go ahead and just number these 0 to 10. And my box part is going to go from Q1 to Q3, so from 4 to 9.5. So I'll start with that. Next thing I'll do is I'll mark my median at 8. And then I can make my whiskers. So the whisker goes down to 3 and up to 10. And if you look here, these are your graphing CFU scores. They're not actually scores from you all, but you can see that's just an example of some data we might look at here. From there, then we're looking at, in this case, the questions ask us about percentage of students. And so we want to remember that our 5-number summary splits our data into 25% pieces. So when I look at the percent of students scoring higher than a 9.5, well, that little piece automatically is just 25% of my data. If I look at the percent of students that scored below 4, well, that's also 25% of my data. And each of these chunks here and here are both 25. So when I look at the percent of students that are in the IQR inside the box, well, that's 50%. I've got a 25% below the median, 25% above the median. So 50%. When we ask what is the IQR, if I'm just saying what is the IQR, I'm asking for the actual single number that is the range. I'm taking the Q3 minus the Q1, which in this case is 9.5 minus 4, which is 5.5. And then that last question, what percent of students got a 4 or higher? So if I go from 4 all the way up, well, this part's 25, this part's 25, this part's 25. So I've got a total of 75%. On my last one here, this one is 40 students that were surveyed, asking the question, how many minutes do you take to eat breakfast? So on this one, we're going to go ahead and not make this graph in Desmos. Because this is 40, and we're thinking about splitting it into a 5-number summary and into quartiles, that means our data is split into 25% or into quarters. Well, if I've got 40 students, each quarter of that is going to be 10 students. So it's actually pretty easy here to just count the data points and figure out where we're at. I'm going to go ahead and mark my minimum is 0, my maximum is 12, and I'm just going to go ahead and count off 10 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So somewhere between the 10th and the 11th student, that would be our Q1. In this case, they're both 2. So our Q1 is 2. To get to our median, I'm going to count all the way to 20. So there's 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20. Those two numbers are representing our median, but they're both 5. So our median is 5. And then to get to Q3, what I'm going to do is, rather than counting all the way up to 30, I'm going to actually start here and count back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those two numbers are giving me my Q3, which they're both 10, so it's 10. Then I can go ahead and create my box plot here. There are not actually enough spots on here, so I'm going to extend it a little bit. And I always, again, start with my box. So from 2 to 10 is my box. My median is right at 5. And I've got whiskers going out to 0 and 12. Then I can go ahead and answer these questions. So it says, what is the highest value in the top quartile? So the top quartile is this chunk right here, this whisker. The highest value is right there at 12. What values are included in the IQR? Well, that's the box. So the box has values all the way from 2 up to 10. What values are in the bottom quartile? Well, this whisker here is the bottom quartile. That goes from 0 to 2. The mode, if I'm looking at the mode, I'm probably going back to this dot plot, and you can see the highest bar here is 10. And that bottom question there, the median, we'd already found the median. It is 5. Now, I'm not going to go ahead and find the mean. If we had used Desmos to find our 5-number summary, we could just type mean of L. But in this case, I'm not going to add up all 40 numbers or make you add up all 40 numbers. What I will do is kind of ask you, where do you think that mean should be? And since that mean is the average, it's probably pretty close to the middle here. So our median is 5. I would bet our mean is very, very close to 5 in this case. Our data is not perfectly symmetrical, but it is pretty close. There's about the same number down here as there are up here. It's probably maybe just a little bit higher than 5 because of this gap right here. And it turns out, if you want to know, the mean is about 5.6. So there's our lesson for Stats Lesson 3 on box plots. Tomorrow we'll be working on the proficiency practice, the CFU, and the Delta Math.